Okay guys, so we are late to the contest, today's contest, but let's give it a try. 45 minutes remaining, okay. Let me open up my editor. Close all the unnecessary tabs. And let's look at the problem. Construct an array. You are given an integer n. You need to construct an array of n numbers such that an individual element is 1 to 2i. The elements of the array adjacent are pairwise distinct. Uh, the sum of adjacent elements are pairwise distinct. In other words, among the numbers a1, a2, a3, a1 plus a2, there should be no two equal numbers. One line in output, uh, for each test case, output an array of length n. So that's the condition of the problem. Okay, sum of two numbers should not be equal to the third number, pairwise, right? So what we can do is a higher number, a decreasing order will work. There should be no two equal numbers adjacent, right? If we write a decreasing order array in adjacent, it will never be same, but it can be if they are distinct. So this works, right? Let's try it. Okay, let me read. Okay, all the elements of the array and the sums of adjacent element are pairwise distinct. In other words, all the elements and a pairwise sum is not equal. Okay, so pairwise sum should not be there in an array. How can it be possible that pairwise it is not? Okay, it is not present. So what they have done here is, for one it's one. All the individual elements are different and the pairwise sum is also different. So a1 plus a2 should not be equal to anywhere in this. If these are positive number, these two can never be equal, but meaning, so what we can do, let's say the number is 4. Okay, so what we can do is 4 plus 2 plus 1. Yeah, that's valid. So n numbers, right? So first number can be n. Then what we can do is, if we decrease it by 1, n minus 1, n minus 2 up to 1. put it on performance mode. Yeah, okay. This is a good question for A. I'll also read question B. Hmm. Indistinct integer such that pairwise sum is different. Why is this not working properly? We reload the site. Is it working now? Yeah, somewhat. I think the charging is low, that's why it's jaggedy. Okay, sure. What we'll do is there's even numbers, there's odd numbers. Even plus even is also even. Odd plus odd is even. Odd plus even is odd. Like even, odd. So even will be even, odd will be odd. So there's no way it's same, but it should be different also. But the numbers are decreasing. So right. Uh, three sets. Okay. N. So it is 2 times of n, then 2 times of n minus 1. And there's an odd number. 2 times of n minus 1. This is wrong. Let me read question B. 37 minutes are left. I need to do it quick. At least these two I need to solve correctly without any wrong answers, right? Yeah, sure, I'll try it. No wrong answers. Array sorting problem, an array you have to perform the following operation at most once, or only once. Choose a positive integer as well as a subsequence p of an array. Subsequence of an array is obtained by deletion of several. Okay. Add k to each element of the subsequence. That is, each perform a of I perform that element plus k. Okay. The subsequence of that index is plus k. You need to determine whether it's possible to sort the array in non-descending order, it's ascending order, or same, ascending or same. Non-descending is non-decreasing is either increasing or same. Okay, by performing the operation at most once. Whether it's possible to sort the array. Let's look at the example. In the first case, the array is either increasing or same. Okay, in this it is impossible to sort using this. In third case, you can choose k is equal to 6. It's a subsequence of second element, fourth element, sixth element. As this. Then after this, the array becomes increasing. So what it has done here is there is an increasing array and there is another increasing array. So there are two increasing arrays, but what we can say is increasing array, no, the same array, sure. In third place, it is possible, yes. Here it is same, it is also possible. So yeah, we'll make it same. Here an increasing array 3 and also an increasing, yes, here an increasing array, a same array and an increasing array. No. So there are two increasing array. Okay, there are two arrays. So 8, 8, 3, 9, 4, 10, 5, 11. 8, 3, 9, 4, 10, 5, 11. Let's say 8, 3, 9, 4, 10, 5, 11. So we'll take 8 element here. Then 3 is not, 3 is decreasing. So that will be another array. 9 is increasing. So yeah, we'll accept it. After the 9, 4. And it is increasing here, it should go. Then 10 sure works, 5 works, 11 works. So here we can do plus k such that it is also increasing. It is 3, 4 and 5. It should be such that either same, okay, here difference, up to 6, okay, here 4 certain up to 6, here up to 6, 8 say 3, this doesn't matter, right? So this element and the next element, let's say here it was 3, 4, okay, it wasn't here. 8, 3, 4, 9, 10, 5, 11. Then what will happen is 8 comes here, it checks 3, so no, it checks 4, so yes. Then 9, yes, 10, 5 and 11, yeah, works. Now plus 6, right? Or plus 5 works. Let's try plus 5. It becomes 8, 8, 9, 9, 10, 10, 11. Plus 5 also works. Why does plus 5 work? Because this is 5. Okay. This jump is 5. This jump is 9, 10. This jump is 5. So when it switches, so this is red, blue, red, blue, red, blue. So when it becomes blue to red, blue's last element should be same distance. Blue, red, wait, 8, 3, 4, 9, 10, 5, 11. So red, blue, red, red, blue, red. Blue से red, blue से red. It is 6. Increasing or same, so it should not be less. So red to blue. Okay, these are difficult problems, or I'm not getting the logic. We'll move back to the A. Construct an array. You are given an integer n. You need to construct an integer of n is satisfied. L to n and pairwise sum and the elements, there should be no two equal numbers. In this whole there should not be a single number which is same. Let's start building from scratch. Okay, I'm building an array from scratch. There will be a number a. Let's say we are introducing a new number, that is a plus b. Now there cannot be b present here. Okay, can we do brute force in this? 1 second MB. I don't think so, but we'll try. Let's get the logic. Okay, let's say this is a plus c number, so there cannot exist a c number, but this is greater, this is greater. What can we comment about b and c? B are positive number, it can be greater than a or less than a. There always exists such an array, right? Let's make that array exist. uh, each number can take value from 1 to 2n, and we only need to select n numbers from them such that they all are distinct and the pairwise sum is also distinct from 1 to 2n. Yeah, we'll iterate from 2n, like there will be number 2n, there will be number 1 always. Let's say then I'll add number 2, then 3 will become 0, then we'll add a number 4, then 4 1 5 4 to 6 cannot exist, so there will be number 7, so 9 cannot exist, 7 4 11 cannot exist, 7 to 9 7 4 7 1 8 cannot exist. What 8 9, there will be 10 10 1 11 does not exist already. Sure, is it happening that exactly? And wait, 1 to 2n, and we need to print out any integers. 12 1 2 3 4 8 11 1 2 3 4 8 11. How is 1 2 3 4 8 11 working, man? Pairwise. Okay, okay, that's what I'm saying. In third case, adjacent sum from the sets 8 1 11 2 3 4. Okay, then 8 1 9 12 13 7. Those elements are distinct. 2 1 3. Okay, it is adjacent, 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 adjacent. This was wrong. I'll try again. Pardon. Okay, adjacent, so we'll take 1, then we'll take 2, then 1 2 3 is not valid, then we'll take 4 4 2 6 is not valid, 1 2 2 4 6 is not valid, we'll take 5 4 5, 9 is not valid. So for n numbers there will be n by 2. N by 2 numbers. No. 1, 2, 3. Let's say there is 5 number 1, 2, 3, 4. There is 1, 2, 3. 3 numbers. I'm confusing this, making it too complex. Where did the tabs go? Okay, I'll open another tab. Sure. Let's look at the example. How could have the example been created? Okay, for 6 it is 1, 11, 3, 11, 8, 4, 12. Adjacent pairwise sum should not be same. Yeah, we'll jumble it up, right? We'll make the pairwise number same and then we'll jumble it up. So it cannot be same, right? Let's see. What I'm saying is, let's say this number is 1, this number is n, this number is 2, this number is n minus 1. So this plus this is always same, this plus this is always same. So what happens if we do 1, 2, 3, 4, 5, 6, 7, right? So 1, 2, it becomes 3, which should not be valid. Then we'll do 2, 4, 6, which should not be valid. Ah, logic. There will be a simpler method. Construct an array from 1 to 2n elements. Okay. Some of the elements are pairwise. Distinct. There should not be equal numbers. What did this? How did this come into existence? Since what is the number of elements? 1, 2, 3, 4, 5, 6. Right, 6, right. So 6 to 12. 12. 1 to 12. What's the time remaining? 20 minutes. Okay, I need to do this somehow. What's the logic? There's an increasing order which we increase by k, and there is already increasing order. Okay, we'll do this. I can visualize the second problem, right? So there is an increasing array. Let's graphically draw it. So it is like increasing, right? So 1, 2, 3, and 4, and there's another increasing array. Let's say 1, 2, and 3. So we'll add k numbers to it such that it becomes for this to be increasing, for this is A B A B A B A, right? I'm considering just this. So what's the K? What can K be? K can be, so it has to be max to this. Okay, and increasing, so it needs to be minimum this and maximum this. So minimum this, maximum this, minimum this, maximum this. Minimum value and maximum value. Minimum this, minimum this, this. So if it, the least difference, it is, if it can be greater than least distance, so minimum distance is 2, minimum distance 3, minimum distance is 4, let's assume. So if the minimum distance becomes 2, if we cross that, now we need to, if max of minimum distance, we need to cross the max of minimum distance, so we need to cross 4. So if we cross 4, no, there's something wrong. What's wrong? The K. Okay, can we brute force it? We'll differentiate two arrays. We'll note down the position of these two arrays, and then we'll increment it by some K. K can be, we'll try to brute force it. Okay, let's go. Construct an array. No, the second problem. 1.5 second. Yeah, sure. I think brute force will work. Yes, if we can find a K, it works, right? So what K can be? Try import java dot util dot. Oh man, I'll need autocomplete. An array. Okay. So d1 d2 and d1 equals to 0 and d2 equals to 0. Then we'll just iterate. Okay. So we'll start from the first index. The first index, d1 equals to a of 0. Then we'll go to the second element. If b of, if a of ith index is greater than or equal to is greater than equal to d1, then we need to note down I in an array, and a1 is a new int of size, and let's say, and a1 of 1 equals to 1, the first position. It is I plus 1th position, greater than equal to, so a1 of some counter c1 is equal to c1 plus c1 equals to So first index is done, then we'll go to the second index, then we'll go to the third index. So C1 plus plus. Uh, else else if that position then that position is greater than d2. Okay, then and we'll also update d1, right? So d1 equals to a of I if a2 will need to initialize c1 equals to 2. Yeah, I've done that. There are two increasing arrays. Should I separate them? No. It's push and pop, man. I want to do that. Okay, if it comes in this, then this. Else will directly build a second integer and check them. A2 of d2 equals to I plus 1, d2 plus plus. No, d2. What is d2? d1. What was d1? d1 was the value of that element. So d2 equals to c2 plus plus, and c2 will be 0. I've jumbled it up. Okay, d is the value, c is the index, array index, and these array are the positions. Why confused, right? So let's just do this. Position equals to this, and will then increase, and it will go iterate. Else so we have built arrays a1 and a2. These are the positions. Now we need to brute forces. Uh, can we compare arrays? Foreign 0, right? C2's final first element. implies first index. Okay, we'll start from 0, right? uh, c1 equals to 0, c2 equals to 0. Okay, d1 equals to if a of I is greater than of c of 1 equals to c1 plus plus or c2 plus. Else, what is a of 0? a1 of yeah, sure, a1 of c1, which is 0, equals to 0, and c1 plus plus. Int I equals to 0 till I is less than c2 I plus plus j. uh, for n j equals to 1 till j is less than, what will be the k number? K can be mat.max. Will sort an array. B of I equals to A of I and C of I equals to A of I, let's say. Okay, so uh, tell sort will need to sort that mat dot arrays dot sort a a of n is less than a of n j plus plus. Okay, for in this we are adding indexes b of so we'll reset the array b, then we'll increase the p of c of I. What is c1 or c2? Will do c, no, we need to check. So increasing, so this will be the first one. It can never be this. Yeah, it can never be this. So c2 of I plus equals to j will always this. Okay, then there's another loop for int I equals to 0 to n plus plus if b, if b of if the b at I less than n minus 1, increasing or same, right, is less than equal to b of I plus 1. It should always is not less than If it is true for always, if it is false, in all case. Flag 1 equals to I'm going a lot more complex than I need to write. What's the time remaining? I guess 5 minutes. Yes, at least first question, man. It's gonna affect my rating very much, but there's no need. I don't need rating at all. Okay, fuck that. I'll just do the logic now. There's no need of solving it. You are given integers. You want them distinct. You want the first n elements and the pairwise sum of n elements to be distinct. N elements are distinct 10, and after that the pairwise a1 plus a2, a2 plus a3, these all should also be distinct. Distinct. How can this be achieved? How can this be achieved? Let's say it's 2468. Okay, 2468. Then what is, no man, it's a plus 2, a plus 4, a is 2. There's the hint. It is all numbers are from 1 to 2n. That's the hint. What does this mean? N elements from 1 to 2n such that they all are distinct and their pairwise sum comes distinct. A, B, C, D, E. This is A plus B. This is B plus C. C plus D. D plus E. And these all are distinct from this. So let it be if A plus B becomes greater than E, then surely all will become greater, right? Like this is what's the time? Time's gone. Okay, the dev 2 is over, and I have in 45 minutes I haven't solved a single problem. Nice progress. Okay, sure. Thanks for watching, guys. Love you, Shawnee.